In this video, we're going to graph a piecewise defined function. They give us f of x equals absolute value of x if x is less than 2, and then 1 if x is greater than or equal to 2. So first thing I want to do is I like to mark that this is the first line and this is the second line. And then I'm going to kind of mark 1 and 2 here, and I'm going to evaluate some numbers at the first function and evaluate some numbers at the second function. So I'm going to say that this is, let's plug in 2. We always got to plug in the endpoints, f of 2. But when I plug in f of 2, I know that this is going to be an open dot. And the reason it's going to be an open dot is because 2 is not a part of the absolute value of x function, or a domain. So I write open to make sure that I know that I put an open dot on the graph. And then I'll pick something to the, let's pick like f of -1. And then that would be closed. So I got an open dot and a closed dot. Then I'm going to do the same thing with f of 2. For the bottom equation, that's what this 2 represents. The bottom equation, I've got 2 greater than or equal to 2, so this is going to be a closed dot. And then I'm also going to evaluate f of 10. And when I evaluate f of 10, that would be a closed dot as well. So f of 2, when I plug it in, I get absolute value of 2, which is 2. So my coordinate there is, all right, 2 comma 2 right here. Then I plug in -1, I get absolute value -1, which is 1. So my coordinate there is -1, 1. Plug in 2 to the bottom function. Well, it tells me it's automatically 1. And the 10, when I plug in 10, I also get 1. So this is 2 comma 1. And this is 10 comma 1. So when I go to graph it, I'll start with the leftmost domain. So I've got 2, 2, which it said it was an open dot. So that's 1, 2, 1, 2. So 2, 2 is open dot right here. Then I go to -1, 1. So I go -1, 1, which is right there. You know, just thinking about this, I should probably plug in a couple, let's see. I should probably plug in a couple in between here because it looks like it would be a straight line, but because it's an absolute value function, I better check to make sure that we don't have a v going on here, because that's usually what absolute value functions look like. So I'm going to say f of 1, which would be a closed dot, and then f of 0, which is still a closed dot. And when I do that, I get, plug in 1, absolute value of 1 is 1. So that would give you 1 comma 1 here. And then absolute value of 0 is 0. So you get 0 comma 0 here. So let's mark both of those dots, closed dot there, closed dot here. So this function looks like so, with an arrow pointed that direction. And then I look at the next piece, which says it's 1 if x greater than or equal to 2. So I go to this 2 comma 1 piece, it says it's closed. So 2 comma 1, that's a closed dot. And then 10 comma 1, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 comma 1. Let's close that dot and draw the line going that direction. So that's how you graph a piecewise defined function. The only thing to watch out for is to make sure that you're not missing anything, like any vertexes basically with absolute value functions or quadratics or any polynomial like that.